So sorry, buddy. You can't fit in here. It is just physically impossible. See? I'm sorry. You can't fit. It is physically impossible. The energy that you produce is way too much for the volume and the energy that should be inside of here. You need a physical arc reactor from Iron Man's chest inside of here. A little tiny teeny one that has enough power that Iron Man would have, or even more than Iron Man had. You would need to have what's the thing? The hydrogen collider that they have in Sweden, but compressed down to like an inch to fit inside here in order to compress the matter of your body into this Pokeball. It just won't work. I'm sorry. We'll figure it out though. We'll do the math and we'll figure it out and see if we can do it. Okay? What's up, guys? I'm Johnny Fan, but all things fandom. With that being said, I made a video a couple days ago talking about the quantum mechanics of how a Pokeball works. I basically discussed just the theory of it, the fact that you have basically to have the power of the sun within that Pokeball to transport it in there. You could also transport it into data, which is the theory that would basically break down the chemical component of every Pokemon and turn it into data, and that would then create the no clone theorem, which basically says that you have to destroy the original to recreate a new one, and so on and so forth. So on and so forth. If you want to go check out that video where I discussed the theory of the quantum mechanics of the Pokeball, go check it out. In today's video, we're going to do a deeper dive into the quantum mechanics of the Pokeball and actually do the math to show the work. With that being said, hit the like button, hit the subscribe button, and let's get into today's video. Doing this work, my inner Sheldon came out, doing math with nerd things and so on and so forth. Anyway, we have here a math order. So basically, if the diameter of a Pokeball, is 2.5 inches, the circumference is 7.85 inches, the weight is 5.53 ounces, and the volume is 8.18 inches cubed. That is the measurement of a Pokeball. That's the official measurement of a Pokeball according to Bulbapedia, which is like the full-on Pokemon wiki. Now, in my last video, I talked about how Groudon, one of the biggest Pokemon out there, would have to be decompressed so much that it would have to require more power than the sun. So this time I thought, let's go with a small Pokemon. Pikachu. Pikachu has the weight of 211.64 ounces. I did ounces because I did ounces there, just to make everything even. Energy equals mc squared. Everybody knows that equation. Very simple. Energy equals the mass times the speed of light squared. Very simple. It's a great way to figure out how much energy is needed to convert put a Pokemon in a Pokeball. We're going to start with that. So, we're going to do 211.64 ounces, which is the weight of Pikachu, times the speed of light squared. Speed of light is 186,000 miles per second. Square that, you have 3.4596 to the 10th power times 211.64 ounces would then equal 7.3219 to the 12th power. That's how much energy is needed for Pikachu to possibly be sucked into the Pokeball. Now we're going to do the same thing with the Pokeball weight to see if they match up. Pokeball is 5.53 ounces. Speed of light is 186,000, and we square that. So that's 3.4596 to the 10th power times 5.53 ounces. You then get 1.91316 to the 11th power. Obviously, Pikachu weighs more, so it's going to cost more energy than what the Pokeball should be able to handle. Because Pikachu's energy becomes at the 7.3219 to the 12th power, and the Pokeball's energy comes out to 1.9136 to 11th power. Pikachu's like 7 times that. So, might not work in that sense. So then we have energy equals Planck's constant times the frequency. Now, in order to calculate the frequency, I had to determine the frequency of the energy itself, and the frequency approximately equals 6.62607 times 10 to the negative 34th power joules per second. That's important. Now, energy equals Planck's constant times frequency. E equals HV. We did it, look at back. But before we go on the back, I just want to show you some other equations here. We have the Schrondingrs equation. The Schrondingrs cat is a great theory that discusses if you put a cat in a box and walk away, you don't know if the cat is dead or alive until you open the box. So now here we have the Schrondingrs Poke Ball. You put a Pokemon in a Pokeball, you don't know if it's dead or alive until it comes back out. That pairs pretty well with the non-clone theorem, because you're basically breaking down the molecular construct of every Pokemon and forcing it to turn into particle dust inside a little sphere. What if something happens and that dust can't recreate what originally went in there? So, Schrodinger's Pokeball, you don't know if that Pokemon's going to come back out how it's supposed to. Maybe that's how Ditto was created. Who knows? Someone caught a Pokeball, and the Pokeball just, didn't reconstruct it properly and turned into a pink blob. Ditto used to be a Jigglypuff, and so they had to reprogram Pokeballs to make sure it didn't happen. Anyway, just want to throw that out there. Okay, sorry. So before I said we were trying to calculate how much energy, and I said frequency was approximately that number. Forget that. It is energy equals Planck's constant times the frequency. I made a mistake. So I took the energy from Pikachu, equals Planck's constant, which is 6.62607 6.62607 times 10 to the negative 34th power times 1.9136 times 10 to the 11th power. And if you remember, 1.91 was the energy of the Pokeball. So I'm trying to see if we do Planck's constant times the energy of the Pokeball, will the energies match up? Obviously not, because all you're doing is the frequency of the Pokeball so the amount of energy needed to create this red beam here is 7.26767244 times 10 to the negative 22nd power, which doesn't really make sense. Before we get to the bottom part here, we're going to talk about density. The density of the sun is 1.41 grams per cubic centimeter. So the amount of energy that the density of the sun creates is 3.8 times 10 to the 26th power. Yes, that's a little more power than Pikachu. But still, the amount of energy that Pikachu would have to put out to be in a Pokeball is just so dense. The Pokeball should not be able to handle it. Now, to figure out the energy density of an object, you take the energy and divide it by the volume. So, the energy of... So, I did the Planck's constant first, just to kind of like get a rough ballpark of what it would take. So, Planck's constant divided by 8.18 inches cubed is 4.943126481 times 10 to the negative 30th power. Okay, we have a constant number. Now, the energy of a Pokeball, which we calculated before on the other side, was 1.26767244. No, 1.91316 times 10 to the 11th power. You take 1.91316 times 10 to the 11th power, divide that by the volume of the Pokeball, which is 8.81 ounces, and you get 2.3388882 times 10 to the 10th power. That is how much energy density is within the Pokeball. Now, the amount of energy at the center of the Earth is 276.5 watts per cubic centimeter. That's more energy. Pokeball produces more energy than the core of our Earth. The power of a Pokeball must concede the core of the Earth and the power of the sun in order to compress Pokemon into a small confined space. It doesn't work. The math does not work. The amount of energy to create this little red beam to suck in a Pikachu does not work. So please, if there's any engineers out there watching this video, check my work, because, you know, yeah. I have a equation down here that I just wrote down because it looked cool. But basically, the amount of energy a Pokeball would need to be sucking in, even just a Pikachu, is way too much for it that it should be able to handle. Obviously, it's a cartoon, it's anime, it's science fiction, but still, it is physically impossible for a Pokeball to work. I'm sorry, dude, the math just doesn't work. It's impossible. So with the cartoon world, well, it does work. How does it sound? Alright, one gives. Charmander, return. I wish I could do that, actually. So either way, the math does not work. Let me get this back up. So as you can see, the math really doesn't work how it should. However, it obviously it's science fiction, obviously it's a cartoon, but the only other aspect of this working that I can think of is the theorem of basically no cloning. It would have to basically break down the individual Pokemon into data instead of the compressed energy. That could actually work. Just taking that energy, converting it into megabytes or gigabytes, or whatever, you know, data information needs to be put in there. When it goes in there, it saves a file, and then when you release the Pokemon, basically that file is destroyed and reconstructed from the original file, and then therefore the Pokemon comes out. And that is why the Pokemon still carry the same memories. That's why they still know their trainers. That's why they still obey the trainers. That's why they still know the trainer cares about them and have all these other memories, because that file is basically saved in the computer chip. When that original form is destroyed, then a new one comes out. We know that humans can go into the digital world too, because of Ash, Misty, and Brock going into the digital world with Porygon, and then they come out perfectly fine. So when they went into the digital world, their bodies were destroyed, recreated, and then came back out. That being said, the original bodies were destroyed, and this new non-clone is what Ash went on to Ash's journey with. It's hard to say, because this is all, you know, a theory on how this even works in general. Even in quantum mechanics, this is just the non-clone theorem. It is just all theory on how this stuff works. If we prove these theories, we would solve string theory and all these other black hole theories that we have. We would just solve science, and there'd be nothing else to talk about. And if we figured these theories out and we was able to solve these theories, maybe there would be some other kind of math equation to make the Pokeball actually work. Because my math doesn't add up. Maybe I did it wrong. I don't know. You let me know. Anyway, the fact that it doesn't add up and everything needs to be a theory, if you compress something into data, if I take this energy drink and digitize it inside of this, I am physically saving the information of this, the flavor white peach, into a memory chip. It has an image of the can, everything else, the dimensions, everything, all saved within here. This can is destroyed, but when I take it back out, I have a can of white peach. Same size, same shape, same taste, but it's not the same can. But it is the same can. It's a very weird theory. And I don't fully understand how it actually works. But I just thought it was interesting. You know, I did the other video about the theory of the Pokeball, and I was sitting there like, huh, there are simple mathematical equations that you could use to actually figure this out and how much energy would be produced. And it is just insane that Pikachu is 7 times the energy of the Pokeball. So this Pokeball, although its size, would have to have something on the inside of it to be able to produce more energy than what it should put out. And like Groudon, it would need more energy than the sun. Or just don't catch a Groudon. Anyway, thanks guys so much for watching. Hit that button, hit the subscribe button, and I'll see you guys next time. And make sure you check out the links down below. I got a Patreon page. I have a Spotify. I have a merch store. I have a bunch of other cool stuff. Go check it out. On my Patreon page, I got stuff on there just for you. Please, it means so much to me, all your support, so I can continue making wacky, stupid videos like this and do crazy math equations for you. I don't want to do it. Well, it is kind of fun to think about stuff like that. But I want to share my funness with you. So go down below, join my Patreon, hit that join button. It means so much to me. And yeah, Pokemon, gotta catch them all. See you guys next time. Before you go, make sure you check out that video and that one. And do me a favor, comment down below real quick what your favorite Pokemon is. Just want to know. See you guys next time.